Health, Psychology, and Human Nature with André Sturesson. Hey friends, hope you're having a great day. Are you following me on Instagram and Facebook? Please go to Health, Psychology, and Human Nature on Instagram or Facebook, or both for that matter, to get the latest episodes, inspiration, and more. Please take a pause and go there. Also, if you like the episode, please share it with a friend, family member, or somebody else who you think might like it. Hello friends, and welcome back to another episode of Health, Psychology and Human Nature with me, André Sturesson. A science-focused podcast where we explore, learn and improve our lives together. In today's episode, we will get into brain training and if brain training actually works. Then we'll get into cognition and ways to improve cognition. So ways to help our brain to work better. And then in the end, we'll also talk about consciousness and what consciousness is and why we have it. Today, I have Adjunct research professor Bobby Stojanoski with me, who is highly interested in both how the brain works and also our experience. And he studies things like memory, attention, perception. And he also uses quite advanced techniques like fMRI and EEG to measure what is going on in our brain. Friends, I really hope you enjoy today's episode. Bobby, welcome to the show.
Thank you for having me.
Very nice to have you here. I think we're gonna have a good time talking about something very interesting today, talking about brain training.
Yes, I think so. It's a topic I'm quite interested in, and I think a lot of people are interested in brain training. So, very much looking forward to it.
Yeah, for sure. I think perhaps we should just start off by talking about what brain training is. So for somebody who haven't really heard about it before, what is brain training?
So that's a really good question, and it might seem really obvious to some people what brain training is, but there's actually a lot of debate, and it's a fairly contentious issue on how exactly to best define brain training. So I'll break it down into sort of two types of brain training. So what I'm primarily interested in is the brain training that people have probably been exposed to commercially through various types of apps and websites that claim that you can increase your cognitive abilities or you can get quote unquote smarter by playing these online games. And so brain training is basically this concept where you play one or more online games. These are games that are often designed to target a specific type of cognitive ability, for instance, working memory. And the idea is that you play this game, which increases your working memory ability. But again, it could be any cognitive ability. And then as a consequence of that training, then that transfers, and I put an emphasis on the word transfers because I hope we dive into that because that's also a poorly defined concept. But by training on this task, it transfers to other aspects of not only your cognitive abilities, but to other aspects of life. So by training on working memory tasks, that you get smarter, you get a higher IQ, or you perform different tasks in the world better, like you're more efficient at grocery shopping because you don't need a new list and that sort of thing. So at the foundation of the idea is that you play these online games and you get smarter.
Okay, so perhaps we can just give an example of what you just said. So you play some kind of game, and that somehow trains some part or some program of your brain, and then what is thought is that you then will become better at something in your real life, kind of.
Exactly. Yeah. So there's a whole host of tests that you can do. What's commonly a test that's commonly used in the brain training literature and on these various apps is our working memory tasks. And I used that example before. And the reason why there's so
maybe you
much
could say what working memory is, just for somebody who doesn't really know what that is.
Yeah, absolutely. So working memory is your ability to hold and manipulate information in your head. So if I were to say, hey, can you call me back in 10 minutes? My phone number is, and I give you a string of 10 digits, and then you have to go to the other room because you left your cell phone there and then call me. You rely on working memory to hold the numbers I gave you and then remember them in the specific sequence I gave them to you, and then you punch them into your phone. And you can do that because of working memory. And so a lot of tasks basically tap into that type of thing. So there's a task called an n back task, n as in a variable number, so some number of numbers. So what happens with the task is you're given a sequence of numbers, and you're told to press a button every time the number you just saw is the same as the number immediately before that number. So that would be a 1 back.
Right.
If you do a 2 back test, your task is to indicate whether the number you just saw is the same as the number you saw 2 items ago. And then, of course, as the n increases, the task basically becomes impossible, and most people can't do anything beyond 3, 4, or 5 back. And so the idea is that you have to remember the sequence of numbers and identify when there's a repeat some numbers ago. So that's sort of a standard working memory task. You have more simpler designs where you just give a sequence of numbers, like 8 numbers, and you just have to repeat the numbers, or
right.
8 positions on a grid, and you have to repeat that sequence. And the reason why working memory is often the focus of these brain training tasks is because of an assumption, and it is assumption because there isn't clear-cut scientific evidence that this is the case. But the assumption is that working memory sort of forms the foundation of all cognition, that it's sort of the basis of all cognition. So in order for you to do any type of higher level cognition, like communicating with others, or following a plot in a movie, or planning your day, or planning a trip, or planning a trip to the grocery store, all requires working memory. And so the idea is that if you boost working memory, if you improve working memory, then you sort of automatically, because it's the foundation, lifts or elevates all other aspects of cognition.
Right. Okay. Yeah.
So I think your question was to describe a bit more about what working memory tests are and why working memory tests are used. And those are the main reasons that they're the other advantage is that they're easy to implement, they're quick to do on online apps. The working memory literature has a very long, rich history of scientific studies. So it's a very well-established concept. And for those reasons, it's become sort of a focus in the brain training literature.
Right. Okay. So you do some kind of game which is supposed to target something like working memory, which you just described. Then you're supposed to get better at things in your everyday life, and this is where transfer comes in, right? Maybe we can talk about what transfer means.
Exactly. So after you've done the training phase, I should add that all brain training studies contain 3 phases. So you have the training phase, which is you have the phase 1 is the testing phase, the initial testing phase. So this is a set of tests that you're going to use to see whether or not the training had any effect, right? So the only way to know whether brain training works is to show that you improve on some test above and beyond what you expect to the improvement you would expect without brain training, right? So if you just if you did a test, for instance, if you did a language test and then you just sat on the couch for a month and you did the language test again, you wouldn't expect much improvement because you haven't done anything to help you with that language test. And the idea with brain training is you do the language test first, or an IQ test, or whatever it is, and then you do the training. And it's because of that training that when you do the test task, what's commonly called the test task, which is the test you did in phase 1, which is the language or the IQ test, then you get much better at that test.
Right.
So all brain training studies have those is defined in these 3 phases. So phase 1, you select a set of test tasks that you want to see whether or not you've improved because of the training. Phase 2 is the training period itself. And then phase 3 is completing the same tests that you did in phase 1 to see whether or not the training actually improved your performance on those tests.
Okay, right.
And so this is where the concept of transfer comes in. And this is, it turns out this is actually an incredibly messy concept that's really poorly defined. And in my opinion is actually the cause for a lot of the inconsistencies in the literature. And so the idea of transfer is that if you do a brain training, if you train on we'll go back to our working memory example on the NBAC task. If you train on the working memory task, then you want to evaluate how far that training transfers. So you could do so your test task. You could choose a variant or a version of the NBAC test. So for instance, you could do an NBAC of number sequences and then test on letter sequences. And in this case, it would be something akin to, or something similar to either direct transfer, which is basically performing a task that is in many ways identical to the training task. Or you can have near transfer, which is improvements on a task that is quite similar, but not basically identical to the training task. So, for instance, you train on an NBAC with number sequences, and then you test on a working memory task that requires spatial memory.
Right.
And that would be evidence of near transfer. And then far transfer would be an example of far transfer would be training on a working memory task produces benefits to things that are completely unrelated, to tasks that have no similarity with the training task. So for instance, you train on a working memory task and you have a higher IQ.
Right.
Now I've given you sort of clear-cut examples of what near and far, direct, near, and far transfer are. But of course, each of those categories have a range. And that range is sort of a cause for a lot of the inconsistencies in the findings, because the challenge is, how do you determine whether or not 2 tests or 2 cognitive abilities are related to each other? And this is actually a profoundly difficult thing to do.
All right, but okay, so this is basically what you do then, and then you got this transfer. But I think what everybody then probably wants to know, if they're spending all their time on brain training and if they bought this program, is like if it actually works. So does this brain training work?
So I'll give you the short answer, and then I'll follow that up with a slightly longer answer. The answer, and the answer is no.
Okay.
There's no evidence that. So from my work, I don't find any evidence for any type of transfer. You always find evidence for direct transfer. You get better on the thing that you trained on.
So can we just pause there just so that people understand what you say. So basically what you're saying is that if you're training on a specific game, you will get better on that game, but nothing else. Is that correct?
Exactly.
Okay.
That's correct.
Okay.
Exactly.
Good.
That's what I found, and that's what I found, and that's what a lot of the literature has also found. Now, again, I'm talking about this particular type of brain training. Earlier I mentioned that there's a second type of what could be considered brain training, and that is specific programs in rehab settings, for instance. And this is a slightly different literature, and there's some evidence that in clinical settings, after brain injury, for instance, you can introduce programs that are similar to brain trainings that do have some sort of impact, but it's still unclear whether those benefits are related to the types of benefits that the brain training that I'm talking about sort of claim to make.
Right. All right.
But yeah, so no, yeah. So I was gonna say, so yeah, to answer your question again, in terms of these working memory online games that you play, there's no evidence that you get better on anything beyond the game you're playing.
Right. But I think it is very interesting because when before our talk here today, I looked at some different studies and stuff on the internet, and I found one. You heard about the active study, probably, right?
Yes.
Yeah. And in that study, I took a look at that, and they made some claims that, I mean, this is quite a big study of like 2,800 people, and it's a randomized controlled trial, so it's supposed to be a good study. And then, of course, you know more about this than me, so we'll get into that. but I mean, they made some claims that your brain became faster, also with things that didn't have to do with the game, and also, I mean, they made claims like it was good for dementia, for example. That 10 years after they did this brain training, that they were 33% less likely than controls to develop dementia, and all these other things. What have you taken a look at this, and what do you think about all of this?
Yeah, so my memory for the exact details of the study are a bit vague.
Yeah, of course.
But it turns out when you look at that data, you see a couple of sort of important nuances, sort of subtle things that they report. And one is that, first of all, the tests that they use aren't. So I go back to this concept of transfer and defining how similar or how different the tests are, and that's sort of not clearly defined. And a lot of the tests they use are actually really similar to the tests that they trained on. The other thing is, if you look at the graphs of improvement, and I don't expect anyone to do that. That's sort of my job to look at those figures. But it turns out that a lot of the control groups in a few of the tests, the people who did nothing actually improved sometimes just as much as the experimental group, or that is the group that did the training. In some cases improved, I think, in one or two tests more than the group that trained.
Right.
So, and this is what I mean by sort of the inconsistencies in the finding, that there's even in that paper, but if you go sort of beyond that paper to the literature as a whole, you find that there's some evidence that, okay, in some cases it seems to work. But in other cases, it in very similar contexts, it doesn't work. And that active study is a really good example that, again, there's some tests, there's some outcome measures that looks like the brain training group improved, but in some of the other tests, the control group that did absolutely nothing improved just as much, and in some cases even more than the training group. So it's difficult to sort of reconcile these differences. So why is it that in some cases it seems to work, but in others it doesn't? And this is actually, in my opinion, a good thing, because I mean, the whole enterprise of scientific inquiry is to understand under which conditions experimental manipulations, and in this case, brain training, has an effect.
So in the study, the people that did the processing training, the brain training, they had less risk of getting dementia, and that seems like to be a transfer.
Right. So yeah, the if I remember correctly, it was people who did the brain training. They followed up with them years later and found that so the people who did the brain training are less likely to get dementia.
Exactly, 10 years after. Yeah.
Yeah. So again, there's a lot of there's a number of sort of interacting factors that might play a role in this. So so the first thing I'll say is that what's really surprising is that in this study they make claims that brain training can last 10 years, and the reason why that's surprising is that it's there's no consensus in the literature. There's no agreed upon answer as to whether or not brain training works at all. Sort of independent of my research, in my opinion, it's not a general agreed upon opinion that brain training works. Two, there's absolutely no consensus about how long one needs to brain train in order to produce transferable benefits. Three, and then the next thing is, well, if we don't know if it works at all, and then let's just sort of assume that it does work. We don't know how long you need to do it in order for it to work. And then the third thing is, well, let's assume that it does work. Let's assume that you've passed some minimum threshold required to produce the benefit. Then there's absolutely no evidence, and there's very little work looking at even if it does work and you've passed the threshold, how long those benefits last for. So that's one thing. Another thing I would say is that there might be a sampling bias. So, for instance, it might be that those who agreed to do the brain training study in the first place might be less likely to develop dementia in the long run.
But it just seems like, they also made claims here in this study that people who did this brain training of the process beta in the brain, that they've also said that they were, I think it was 50% less likely to be at an at-fault car accident and this kind of stuff. But you still think that it doesn't have to do with this stuff.
I think, so it's my take is that it might, and there might be some benefits to brain training, but if my take on these sort of things is, if you're going to make extraordinary claims like these things will have benefits 10 years down the road, and it might help prevent or slow dementia, or you become more careful or more aware of your surroundings in the sense that you get fewer at-fault car accidents, then that would require sort of a tremendous amount of evidence to support that claim. If you think about other aspects of sort of science or medicine, if you had a drug, for instance, that could cure something, or if you had a drug that could delay dementia, this would require mountains and mountains of evidence that's replicated over and over again in order to support it. It would be very surprising if the scientific community just said, "Oh, there's a few studies that say it prevents dementia, and an equal number of studies that it does nothing." Right. That wouldn't. I don't imagine that drug would ever become recommended.
No, of course, that would be risky.
So.
Right.
Yeah. So with brain training, I mean, and I don't want to sort of compare the two directly, because the brain is super complicated, and there's, of course, we can learn and we can improve, and so I don't want to take the hardline stance that this is never the case, or it could never be the case, or it's absolutely wrong, because there's no such thing as absolutely in science. So my point is that when you look at that study, there's some red flags that come up for me that make me think, okay, how real are these effects? And then let's look at what else is being done in this area, and sort of evaluate it as a whole package.
Right. So what, again, you mentioned before, what is the consensus then about brain training and its effects?
So in general, there's sort of a split. There's
two different teams.
There's sort of two camps. Yeah. So there's a camp that, actually, I'll add that there's sort of a third camp emerging in the recent work, and that is, so the original camp is one side of the camp is the people who are doing the original work showing that this does work and that there are benefits. And again, this is their intentions were good, and the hypotheses came from a good place. So the whole idea of brain training basically stems from neuroplasticity, that your brain can sort of rewire itself in different contexts. And there's lots of evidence that that's true. And so the idea was that, well, okay, if the brain can rewire itself, then we can train the brain to rewire itself to help with cognition. And the problem is that that leap isn't isn't well supported. So yes, there's brain plasticity, and yes, it happens a lot in different contexts. But the leap from the fact that there is brain plasticity to training on working memory tests or any cognitive test online for a half an hour or an hour a day is gonna produce these global benefits to cognition. Those leaps aren't founded. That's sort of the main source of controversy, and where sort of my work has come into test explicitly. And then there's and the other camp is saying, well, okay, you made these claims, but when we look at this data, there's a number of things that are cause for concern, and we want to reevaluate. And we've looked at over and over again, there isn't much evidence for it. And then I think there's a new camp that's emerging now, that's sort of saying, well, let's move away from this idea that you can from this very strict definition of brain training, the one that we're talking about, this play a few online games for a couple hours a week or whatever, and then you get smarter. And instead, start looking at what happens to cognition, to thinking, different aspects of thinking, and of course, what's happening to the brain itself under different types of quote unquote training. But these aren't online games for a few minutes. These are sort of more robust, intensive, lab-based exercises that you do for longer periods of time, sort of more similar to what you would expect in a clinical setting, and seeing how that changes cognition. So for example, and maybe you'll ask me this later, but often I'm asked, well, is there any evidence of brain training? Is there anything that we can do to improve cognition? And my answer is always yes. There is a brain training program that exists that's very well established, and it's called school.
Yeah, yeah.
But the problem, of course, is that we actually don't know why school improves cognition. That itself is a whole area of scientific investigation.
How does it improve cognition? School.
Well, so those who go to school and those who are in school longer have higher IQs, have better jobs, make more money, live healthier, live longer. There's all these benefits to having higher IQ that's linked to education. That's directly linked to education. So it does help, but we don't know what the mechanism is. We don't know how it helps, right? And of course, school is very, very expensive and very, very time consuming. And you have music classes and math classes and physical education classes and arts classes, and all of that sort of has to come together to help with cognition. And brain training is sort of like the magic it hopes to create a sort of filtered, condensed version that is a magic pill of school. Yeah. But there's no evidence that seems to work.
But is there no evidence at all that isn't there anything that works when it comes to brain training, like this kind of brain training that we've been talking about before when you do this kind of games?
Again, the short answer is I'm not seeing any of it.
Okay.
Yeah, I'm not seeing any of it, and that's not to say there are no studies that do show it, but the studies that do claim to have some support for it have a lot of these things that I discussed earlier aren't well defined. So this idea of transfer, right? And maybe I'll spend a few minutes going into a bit deeper on transfer and sort of why defining the thing you train on and your outcome measure, your test task, quantifying those is so important. So if and a lot of this stems from sort of the history of cognitive psychology, that cognitive abilities have often been put into box and arrow models of the brain and how cognition thinks. That you have a box for attention, you have a box for working memory, and you have a box for inhibition, and so on and so forth. And the brain training world sort of says, okay, well, we're going to take that assumption as truth, and you improve on one box, and all boxes sort of improve. But the problem is that the brain doesn't work that way, and the brain isn't bothered very much whether humans invent boxes with labels on them or not. It's sort of the brain does what it does, and we try to find ways to make something as complicated as the brain easy to understand, easy to study, but doesn't necessarily mean that it maps out that way. So if you have a training test, and like an NBAC test, and then you select a working memory test that's based on spatial information, how similar are those things?
Yeah.
Right? So I'm describing them in a way that makes them seem like they're really similar, because I'm saying working memory with numbers versus working memory with space. But how similar are those really? And what are the tools that you can use to really extract or quantify that similarity? Now, I have some suggestions, and I've done this in a couple of studies that I've recently published, and to think about ways of saying, okay, if I have this test and this test task and this training test, how can I quantify their similarity? And just using labels, I think, isn't good enough. And this is where I think a lot of the confusion comes in, because you could say, well, I have a working memory test with letters, for instance, and then I test on words. So where exactly is the overlap, right? On what dimension are they similar? So you could say one's a language task, one's a working memory task. So they're completely different. But then you say, well, one has letters, and the other one has letters, of course, because it's a language task. It has words. So how exactly are they similar or different? And then, and of course, it's not enough to say they're similar or different. You want to know how similar or how different they are. So it's only then you can say, okay, these are similar by 62%. So then you can say, okay, I expect this amount of improvement. But until that's sort of really well established, then looking at brain training studies in the literature, it's very difficult to evaluate whether what they're showing is just direct transfer, that is just practice effects, or there really is some evidence for near and far transfer. And if you look at studies, for instance, you look at, I go back to the example of the NBAC task, this working memory task using space or numbers or letters. There are different studies that use the same test, and I've done this in one of my studies. I've used the same test on different outcome measures and find different results.
Right.
So if brain training is going to be real, then it has to, if it's a real property of our brain, it has to be found consistently in the literature.
Right. It makes me wonder, like,
I don't mean to, sorry, I was going to say, I don't mean to put a damper on things, but I think it's important to sort of evaluate the literature as accurately as possible.
Yeah, for sure. And I mean, if somebody, if it doesn't work, and then people spend hundreds and hundreds of hours on it, then of course that is not the best use of their time as well. So of course we want to make sure that everything that we do actually does what it's supposed to, right? So.
Yeah, just to speak to that, and part of the reason why I'm sort of interested in brain training and happy to talk about it with as many people as possible is that this is an enormous industry. This is a $1 billion a year industry with their estimates from about a year ago that there are 80 million and approaching 100 million active users of these online brain training programs. So it's not just massive amounts of time that's being spent, but it's massive amounts of money that people are paying in hopes of getting smarter. And so, and I'm not against the idea of these things working. I think it would be amazing. I would love for it to work. It would. I talked about all of the sort of benefits of improving cognition. The higher your cognitive abilities, and sort of a simpler saying that the smarter you are, your quality of life overall is just much better. You have a better job. You're paid better. You have better access to medicine. You live a healthier, longer life. So it is important that if it is true that we can improve cognition, then we should study this. But we should also be honest about ourselves and with our studies about the claims we're making.
For sure. I was thinking about cognition then, since it's so very important. Like, except for school, what is your best tips if you want your brain to work as good as possible for as long as possible?
Yeah, so that's a really great question. So I'll start by saying this: if you enjoy playing online games, and that brings you intrinsic value, like if that's something you like to do with your time, without the expectation that it's going to make you smarter, then you should spend your time doing this. So I think of crossword puzzles or Sudoku. If you enjoy doing those games, you should do them because that makes you happy. Just don't expect that your IQ is going to skyrocket after. But beyond that, there is a lot of work on other lifestyle factors that help with cognition. So I would say primarily, or of utmost importance, and it's another area that I have some work in, is sleep. Sleep well. This is it's just so important, and it's a thing that we all know, we all agree, we all want to do better, but often we don't.
Yeah.
And it can have really negative effects. So sleep well. I actually published a study about a year or two ago where we had about 10,000 people from all over the world tell us about their sleep patterns. And then we measured their cognitive abilities using an online cognitive platform called Cambridge Brain Sciences. Anyone can go see these tests. If you go to cambridgebrainsciences.com, you can go see the test. You can do the test yourself. But we had about 10,000 people tell us about their sleep patterns, and what we found is that if you need about 7 or 8 hours of sleep for optimal cognition, for optimal thinking abilities. And this is a thing that seems obvious, but actually it wasn't done before. We were sort of the first to really determine the amount of sleep you need for optimal cognition. But less than 6 and more than 9 actually produce deficits in cognition. So get some sleep, and then beyond that, eat well, exercise, and I know we're in the middle of a pandemic, but socializing with friends. Before that meant going out to coffee shops and pubs and hanging out with friends, but online chats and Zoom calls and Skype calls, and those are all helpful.
Talking about sleep, one thing that I wonder about, which I just anecdotally really feel, is when I go in and take a 20-minute nap, then I always feel like I have so much more energy, and so my brain just feels refreshed and being able to work much more afterwards. Is there any science of how power naps affect cognition?
Yeah, power naps are great. There's a lot of evidence to suggest that they're really, really good for how you feel, energy levels, cognition. If you can take a nap, then go for it. The one thing that you should be cognizant, something you should be aware of, is if you're dependent on naps, that might suggest you're not getting enough nighttime sleep.
Yeah, true.
That's all. So napping is great, but if you find that you have to nap to get through the day, then maybe sort of reevaluate your nighttime sleeping.
Right. And about these things for cognition as well, if I would have to make you like prioritize and choose like from 1 till 4 or 5 of these different things, like what do you think, like in what order would you put these for how they affect cognition?
In those factors that I mentioned?
Yeah, or any other factor also, of course, if you have anybody else, but...
Yeah, I would say sleep would probably rank among the top. This is of course a non-scientific list I'm creating here, but sleep and exercise, and of course these two things are very related. The more you exercise, the better you sleep. The better you sleep, the more energy you'll have to exercise. Are really, really important. There's a lot of really good work on diet, including some of my colleagues at Western University here in London, Ontario, looking at sort of the negative effects of sort of sugary, high calorie foods on specific areas of the brain, like the hippocampus, and its effect on learning and memory. So that I would rank that quite high. I would also rank socializing with friends very highly. We're a social species, and it's just very important for us to do that. I would rank sort of games much lower than those other factors.
When it comes to food, like, do you think it's a bigger effect of not eating sugary, hamburgers, pizza, all of that stuff? And how would you rate that compared to pretty much eating like a Mediterranean diet with like good fats and not that much sugar and stuff like that?
Yeah, I would rank that as very important, especially in early childhood, early years of life, childhood and adolescence. You want to maintain a healthy diet. Yeah, good fats, lots of veggies, and really staying away from high sugars, high calorie foods. And the reason why I point out that age group is because this is a time where there are tons of changes, not only to sort of your physiology, your biology, new chemicals are sprouting and spewing all over the place, but the structure of your brain is changing tremendously at this time, and how your brain functions.
Right. So you would say that it's the part of your life when it's most important is when you are like from 0 till 10 or something like that?
Yeah, I would go. Well, yeah. I mean, every part of your life is important. In terms of cognition, I would say that early childhood to sort of mid to late adolescence is really I don't want to use a critical period because that's a scientific term to describe a clearly defined period that sort of shapes who you are, and there's some evidence to suggest that childhood and adolescence is critical. And they're like, for instance, early childhood is a critical period for second language acquisition. That's sort of a good example of what a critical period is. But there's some evidence to suggest that late childhood and adolescence is a critical period for cognition.
Right.
So you see cognitive ability, you see changes in the brain, sort of slowing down in both structure and the physical properties of your brain and its function, and cognitive abilities accelerate. They really begin to improve in childhood and adolescence, and then slow down at between 20 and 30. So in that sense, that is a very, if not critical, it's definitely an important period.
Interesting. What would you say? Maybe this isn't your like the number one thing that you study, but still, what would you say? What is a good diet for your brain and cognition, which is basically the work of the brain?
Yeah, it's definitely not my area of expertise. But speaking to colleagues, the idea is that there may not necessarily be a best diet to have, but there's a best diet not to have,
right?
And that is avoiding pizzas and these like deep fried chicken sandwiches between donuts and
yeah,
that sort of thing is you want to avoid that. But beyond that, I don't. I can't really speak to what sort of the best diet is. No. Again, lots of veggies, good fats.
Yeah, I was thinking perhaps maybe we could shift the subject, because I know that you know a lot about consciousness, and it's something that I studied when I took my second bachelor, and I think perhaps if we can get into that just a little bit before we head off. So maybe if you can, like, if you would explain consciousness to somebody who have never heard about the concept before, like, how would you explain consciousness?
That's a really good question. So you can think about consciousness as a continuum of sort of being completely unconscious, and there are various ways to be unconscious, to being completely conscious or aware. So an easy way to think about consciousness is the degree of awareness. And so there's a person that is So a person can be aware in general. So a person can be conscious, but then there's also another concept that's studied often in the literature is the contents of consciousness. So you can be a conscious being, but you can also be conscious of specific things. I can assess whether or not you're conscious, for instance, by asking you, for instance, if you're conscious, raise your left hand now. And if you do that, I assume that you're conscious. An example of the contents of consciousness, for instance, is so right now, you're not aware of this phenomenon, but I'm going to tell you to focus on the pressure of the chair on your behind if you're sitting in a chair. So this is now a sensation that existed before, but you were completely unaware of until I told you to attend to it. And so that information entered your consciousness. That is now part of the content of which you are conscious.
Right. I really think about the consciousness as what we experience. I mean, when we wake up in the morning, for example, when this entire world just comes into existence, like when we like feel sleepy and we see perhaps our partner or just the empty bed in a room, or perhaps we hear like birds and stuff like that. That is really like how I think about consciousness. This thing that we all experience, and perhaps it's not really 100% correct, but when we're sleeping, of course we're dreaming, then we might also have experiences when we're dreaming. But when we are sleeping, really deep sleep, then we don't see things, we don't hear things and stuff like that.
Yeah, exactly. That's exactly right. So consciousness is oftentimes consciousness is thought about the feelings that you have with different experiences that you have. So the first sip of hot coffee in the morning, or the smell of a rose, or seeing your partner, and of course you can have negative feelings as well. And those are those are sort of the experiences that are often associated, or the feelings associated with consciousness. And you're right. So dreaming is a different part of, or different aspect, or different type of consciousness. Sleep itself isn't a complete loss or lack of consciousness. You're just in a sort of different state of consciousness. Whereas if you've been anesthetized, before surgery, for instance, this is really a complete lack of consciousness. Or an area of work that I'm actively involved in is assessing whether or not patients who have just come out of a coma, or in fact patients who are in a coma, and there is no evidence that they're conscious, because again, the only way for us to determine whether someone is conscious is, using the example I gave to you before, follow this command, raise your left hand if you're conscious. And so patients who are in a coma or just came out of a coma have no behavioral signs that they're conscious, but maybe they are. Another active area of research right now are babies. So babies don't have language, and so you can't just ask them to do something. But are babies conscious? There's some evidence to suggest that they are.
Yeah, exactly.
And what we found is patients who come out of a coma are in what's called a vegetative state. We find that 15 to 20% of these patients are in fact fully aware of their surroundings.
Yeah. One thing that I really find puzzling about consciousness is why we have it. I mean, it could be that we as humans could just walk around without experiencing things. For somebody who hasn't thought about this before, this question might seem a bit strange, but still, it could be that all of us would just wander around and we wouldn't experience anything of life, and then we would die. Like, what do you think? Why do we have consciousness?
Yeah, so that's a really good philosophical question that a number of people in the scientific literature are thinking about, and the answer is we don't know. I don't know. It's at this point sort of just out of our grasp to sort of think about that. So to go back to your point, so most species on the planet have no consciousness, or at least we think they have no consciousness. Insects go about their lives, they do their thing, then they die, and they're often very successful, sort of in terms of evolutionary perspective, but don't need consciousness to live their lives and to be successful. And there's sort of two lines of thinking, and one is that consciousness is sort of a byproduct of our evolution. And what I mean by that is that it didn't evolve for a specific reason, or it wasn't a thing that helped our evolution, but is just there because we have a whole host of other cognitive abilities, and it's sort of it's an emergent property. It sort of emerges out of the other stuff that we have.
Right.
And then the other view is that no, if it exists, it must serve a very specific purpose that's helped our species evolve. And I don't really have that answer.
What if you'd had to make a guess? Like what do you think? Why do you think we have consciousness?
Yeah, I think that's a really good question. I think it serves an important purpose because I think it lets us evaluate the mindset of others in relation to our own mindset. And I think in sort of a social context that our species lives in, then evaluating our own state, and so that not only our own thoughts, but our own being aware of our own body. This is an area of scientific study, is being aware of our own thoughts, our own feelings, our own body movements, and in relation to others. I think that serves an important purpose.
But couldn't we do that even though we didn't have a consciousness? Couldn't we have some kind of non-conscious mechanism for that kind of cognitive stuff?
Yeah, we probably could have. Would our species look the same without it? I don't really know, but it's certainly possible that we could have evolved and been successful as a species without consciousness. There's lots of evidence to suggest that that's the case. And so I guess the question is whether or not we needed it to evolve, and we probably didn't need it to evolve. But did it serve a useful purpose to get us to where we are? That might be true.
Why?
Yeah. So you're really pushing my comfort zones here.
I'm sorry.
No, which is great. So when we study consciousness, we sort of we try to do it by creating as concrete a definition of it as possible. Otherwise, it becomes too difficult to study. But so to go back to this, why it might have been useful in terms of in association with language and the transfer of knowledge, and what I mean by that is, back in our evolutionary history, when one of our ancestors went out and picked a berry, and that berry was not poisonous, and that information was transferred, to other people who then went and searched for berries in the same area, which leads to cooperation and helping others, which of course we know that evolutionarily societies and species that are cooperative are more successful. So there might be links there.
Right. So it might be that during our evolution, it might be that being able to consciously learn about the world and transfer that information, that could have helped us to spread our genes and to become, to survive.
Yeah. And again, just being aware of your experiences sort of fits into that as well. That if you, there's something very pleasurable about, smelling that rose or that smell of your morning coffee. And I think that might be tied into, our social context. A thing that I've really been thinking about is the development from childhood to adolescence, how sort of our shared consciousness develops and evolved.
What does that mean? What does that mean, the shared consciousness?
So what I mean by that is how you and I and others experience something in a similar way. So the smell of the rose, when I mentioned that, you said yes. And that's because it's something that you and I can have experienced, and we share that experience, and that we both find it very pleasurable.
Right.
And there's lots of examples in different aspects of society like that. In fact, one thing that we found and that we use in my studies, in my science, is using movies. So movies is this really amazing way of extracting shared conscious experiences. And the reason why that's the case is that when you and I watch a movie, our brains literally synchronize. Our brain waves begin to align. When you and I are doing something completely different, they don't do that. But when we watch a movie, they begin to align. And we use that as evidence to suggest that, well, if our brain patterns begin to align, then you and I are probably having a similar experience of that movie.
Yeah.
And the reason why I'm particularly interested in childhood and adolescence is that, this is a period where, again, we talked about massive changes to biology, huge changes to the brain and cognition, but it's also a period where your social circle begins to expand and becomes sort of central in your life. We've all been young teenagers, and our friends is all that mattered. And that social circle can have an influence on your own consciousness, and you can have an influence on your circle's consciousness. So the types of things you experience and the types of things you do are going to shape your conscious experiences, your shared conscious experiences. And so in that sense, so going back to why do we need consciousness? Well, in a social setting, if our social circle might be chosen because our shared conscious experiences overlap considerably.
Right. One thing that I found pretty interesting, I interviewed a science journalist about friendship. She said that she interviewed, I can't remember, I'm blanking on the name now, but a scientist who did studies of friends, that friends' brain becomes more similar after they've been friends for a certain amount of time. Yep. Stuff like that. Is that something that you also have read anything about, or?
Yeah. So yes, I don't know too much of the friendship specific literature, but yes, it's true that when you have a conversation with somebody, and the more engaged you are in that conversation, the more interested you are in that conversation, again, your brainwaves begin to look more and more similar. When you're watching a movie and you're both engaged in that movie to the same level, that you both equally like this movie, and of course, different movies are quite good at that, and some movies are just inherently less engaging, sort of boring movies.
Yeah, yeah. The non-scientific term, shitty movies.
Yeah, exactly.
Yeah.
So we avoid using shitty movies in our studies.
Yeah. Okay.
So your brains begin to look more similar, and I think that is probably the root of friendship.
Yeah.
And again, going back to your social circle, when we're really young, we're exposed primarily to family and parents and grandparents and cousins or whatever. And then as you get older, you start valuing your peers a lot more. And then how you choose those peers is I think dependent a bit on our shared conscious experiences. I don't know of any cases. Certainly, I didn't do this. You go to you're in high school and you say, okay, I'm going to be friends with A, B, and C because, for whatever set of reasons. It's, friendship and the formation of your inner circle is sort of an automatic, unconscious process.
For sure.
But I think a lot of that comes about from your shared conscious experiences, and to really sort of make this as nerdy as possible, it comes about because potentially of how similar your brain waves are, and how your brain responds to different things in the world.
Yeah.
It's if you're very musical, for instance, and you have a lot of musical friends, it's unlikely that someone who hates music is going to enter that circle. Of course, it's possible, and there might be friendship is extremely complicated. I don't want to simplify it overly, but I think some of that is there.
Right. Do you think that we ever will be able to know how it is to be somebody else, to experience the experiences of somebody else?
So that's an excellent question, and I think the answer is yes.
Really?
Yeah, and in fact, this is actually I sort of have this as an explicit goal of mine in my research, and that is to understand what it's like to be somebody else.
Cool.
And and what I mean by that is this is of course in a very, very simple way. So there's these these old philosophical papers and debates on what it's like to be a bat.
Yeah, exactly. Yeah.
And I find that sort of philosophically it's a good question, but I don't think empirically it's a very good question because I don't know if a bat knows what it's like to be a bat. I don't know if there's anything like being a bat. That might not be an entity that can ever be studied.
Yeah.
But you can reframe the question in a way that feels more approachable, something that's more a bit easier to tackle. So I'll give you an example. So can you imagine what it's like to be a patient who has Alzheimer's? That is a patient who has some form of mild dementia. Alzheimer's is the most common one. And I think the answer to that is maybe. And the reason for that is actually and this is a great way to merge sort of my two interests, consciousness and cognition. And the reason we can sort of start to think about how it's possible to imagine someone who has Alzheimer's is by thinking about their mental state through their cognition. And so Alzheimer's patients have severe memory loss to the point where they don't recognize family members. But in the early stages, they sort of have more benign or typical memory loss, like they forgot where they parked their car, or they forgot where their keys are, or where their cell phone is, or their appointment that they made. And we've all done this. I regularly forget where I left my keys. I regularly forget one item on my shopping list. And so I know what that I can sort of have a qualitative experience of what it's like to have forgotten something.
Yeah.
Right. And so again, I'm not making the claim that I know what it's like to be an Alzheimer's patient, but I could at least take a very small step towards that question by saying, okay, I've forgotten my keys sometimes. And I know that's terrible. I know what that feeling is like. You're late for a meeting, or you got to pick up your kid from school, and you don't know where your keys are, and that's an awful feeling. So I now have the cognitive component, which is memory loss, but I also have the conscious qualia sort of feelings about that memory loss, which feels awful and terrible, and that is sort of, again, a small step towards understanding what another person is like, which is from its roots in philosophy of what it's like to be a bat. I don't think a bat has ever forgotten their keys somewhere, for instance.
No, that's true. No, exactly. So it's pretty much like if you've been out partying or something, you drank too much beer, or you just had a really, really bad night of sleep, then perhaps you could understand what it's like to. I wouldn't really say that this is really a good comparison, but being burnt out, for example, from stress, that's not the best comparison, I guess. But still, so if you're really, really tired, then you might understand a little bit what it's like of being burned out by stress, for example.
Absolutely, yeah. That's actually a really good example. Yeah, so prolonged, this nicely ties into a lot of the topics we talked about. Prolonged sleep loss. So just having terrible sleep for long periods has huge effects on cognitive abilities, and because of that, you're probably having very different conscious experiences. So
Yeah.
if you're completely sleep deprived, and you're trying to juggle your daily activities and schedules, and then someone brought you that cup of coffee or a rose, then you're probably not going,
Yeah.
this is amazing. The world is wonderful.
Exactly. Yeah, true.
Uh, you're probably thinking, get out of my way. I've got
Yeah,
things to do.
exactly.
So so yeah, that is another good example that and this is the area. This is something that I'm quite interested in. How is it that we can understand conscious experiences through the lens of our cognition? And this again ties back to watching movies. When we watch a movie, excuse me,
No worries.
we watch a movie, we are aware of the mental states of the characters. We're aware of the chain of events that happen in the movie. We're aware of how one character affects another character, and how something they did in the first 5 minutes of the movie has consequences for the last 5 minutes of the movie. And we can use these properties of the movie, and there's a lot of other examples to get at whether or not you and I are experiencing that to the same degree.
Yeah.
And part of that again depends on cognition. For instance, if you have amnesia, if you're amnesic, you might be aware of the mental state of the character in the movie in the first 5 minutes, and know that they've for instance, picked up a gun and they've been carrying it in their pocket, and then that gun appears in the last 5 minutes of the movie. If you have memory loss or amnesia, you've completely forgotten that they've picked up the gun, and there's no suspense to that. That's not an interesting part of the movie. You just realize, oh, someone picked up a gun. Great.
Yeah, for sure. Yeah, I think it's very interesting. I did an interview with Vittorio Galese. He did. We talked about that. How looking at a movie really is something that has been used for us to have these different kinds of experiences, also to be able to understand like a lot of things a lot of experience that you otherwise wouldn't be able to understand, kind of.
Yeah, exactly. The movies are. I'm quite fascinated by using movies in the science, because it's a really close approximation. It gets as close as we can to real life experiences.
Yeah.
You talk to different people during the day; they have an impact on how you feel. You had a terrible interaction with your partner, and then you go to work and you're grumpy, and then you have a terrible interaction with a coworker, and then you make them grumpy, and then so that sort of like chain of events, our own lives sort of have a plot on a day-to-day basis, and beyond that, and so movies sort of capture that to some degree.
For sure. I think we've been talking about some pretty interesting stuff. So we started off by talking about brain training, and then we talked a little bit about how we can improve cognition, and then consciousness in the end. And as a last question, I would like to ask you, like, what do you think is the take-home message from today's conversation?
That's a good question. The take-home message is that I hope everyone is interested in our well-being, and by that I mean human species. We're interested in how others feel in relation to ourselves. I hope people are interested in self-improvement. I hope people are motivated to improve all aspects of their lives, ranging from what they eat to amount they exercise and sleep. I hope people have an active drive to think critically about everything in their environment, and take an approach to pursuing truth and finding truth in your own lives, and in using science to help yourself and others in your environment.
But I think that's really, really. I think that was a very, very good take-home message for everybody. So I would like to I would like to end by just saying big thank you for taking the time and to sharing your knowledge and everything that you learned with me and all the listeners out there. So big thank you for coming on.
Yeah, thank you. This was really great. I had a lot of fun. Thanks for having me on.
Hope you enjoyed the episode. Friends, I really need your help. I'm trying to get the podcast out there. So I was wondering if you could help me by leaving a positive rating and a review on your Apple device or the podcast player that you're using, as well as subscribing to the podcast. That really helps getting the show more visible on iTunes and other players. And if you don't know how it's done, then YouTube has a lot of great videos, so you can search there. All right, that's it. Take care.